So now for example number 4, now that we kind of know what we're doing, we're being given a scenario where it says a bag contains 20 $1 bills. So we have 20 $1 bills. Okay, and then we have 5 $100 bills. That's $520, by the way, if you're wondering. You randomly draw a bill from the bag and set it aside, and then randomly draw another bill from the bag. Find the probability of what will happen. So then they give us these events. So event A, your first bill is a $100 bill. And then event B is the second bill is a $100 bill. Now, if you think about this, this is what we would call a replacement. Remember, I just said in the last example, or no, it's not replacement, it's withdrawal. Because you're going to take the $100, you're going to physically remove the $100 bill, and you're not going to put it back in the bag. So that means you're going to have less $100 bills, so that changes the probability. So then notice that your outcomes, you've got 20 bills in the bag, right? So for event A, the probability of A occurring, at the beginning you have 25 bills. You have 5 $100 bills and 20 $1 bills. And you're going to reach in there and pull out a $100 bill. Well, there's 5 of those in there. Okay? And so that would be 1 out of 5 if you reduce it. Dividing the top by 5 gives you 1, and then you have to divide by 5 on the bottom. And that gives you these two, 1 over 5. Now the probability of B occurring, given that A occurs, now this is different. Now that I've withdrawn a $100 bill, now I only have 24 bills left in the bag. And then of those 24 bills, I only have 4 bills left in there. Now if I divide the top by 4, I get 1, and then remember, if I divide the top by 4, then I gotta divide the bottom by 4. So that reduces down to 1 over 6. Now to find the probability of both of these events occurring at the same time, because it's dependent. How do I know it's dependent? It's a withdrawal without replacement. Another way that you could think of that is without replacement. I'm not putting the $100 bill back in. Okay? So then that would be equal to the probability of A times the probability of B occurring, given that A occurred. So to find the total probability of the first two $100 bills, first and second $100, would be the probability of A, which we said was 1 over 5, times the probability of B given A, which we said was 1 over 6. 1 times 1 is 1, and then 5 times 6 is 30. So it's 1 out of 30, which is approximately 0.0333. Now if I move the decimal over, you have a 3.33% chance of that occurring. In other words, if I take this bag and I reach in there twice, and I do it 100 times, of that 100 times, about 3 times I'm going to get 2 $100 bills. All the other 97 times I'll get something other than 2 $100 bills when I pull them out. Okay? How did I know it was dependent? It's dependent because it's withdrawal. In other words, we're taking the money out without replacing it. Okay?